Hello again, everyone. In this tutorial or demonstration, we're just going to be going through one of our GitHub repositories that we opened up dealing with multi-class image classification. And so this is just a beginner structured GitHub. It does come with the data set. I'll go ahead and show you the data repository or the actual imagery data that we're going to be working with. If you can see here, we just have a bunch of different logos. So it's going to be logo identification. We have Adidas, Alienware, Apple, Louis Vuitton, Mercedes, Microsoft, Nike, Nvidia, and Ubuntu. And if you look inside one of these folders, we'll go into Alienware since I'm a huge fan. It just has roughly 100 images, 100 different images of that specific brand's logo that we're going to be trying to use to classify with either a PyTorch, depending on your particular bent, a PyTorch or a TensorFlow model. So let's go ahead and start looking at the code and get right to it. So the initial notebook that you're going to be using is the one called the image utilities. And what that does is it basically formats, cleans up the imagery data in those directories, uses the folder names as classes. That's why it's important for you to lowercase and remove any spacing in the folder structure. If you notice, we have the GitHub that actually shows you what the folder structure should be. And so it's preferable just to have the folder name lowercased without any spacing. And if you need spacing, just put like an underscore. And then in each of those folders, don't have any subdirectories. Just have all of the images based on, or that were related to that class that you want to run through at that point in time. So what we do is we load our libraries, and here this is just a little quick check to make sure that the directory structure is enforced. We generate new folders that if they're non-existent, we go ahead and generate it, because the logs, obviously that's where our logs are going to be written to. The models directory, that's where we're going to place our finished models. And the runs are where we're going to put our charts to show that we've balanced the actual data set, as well as our confusion matrix after we complete this process. The run complete is just a little check that I have at the end of this notebook, where if you want to run straight through the data prep side and then run the actual trainer notebook, you could just set that to true, and at the bottom of this notebook put the actual PyTorch model trainer or the TensorFlow model trainer notebook name in there, and it'll go ahead and run it from this notebook. So that's just, I have it set to false right now. The augment images, what that does is just a way to add, I don't necessarily call it synthetic data, but it's just a way to add extra data to train with to give your model kind of more variability. And what it actually does is for every image in the directory, it creates a copy rotated 90, 180, and 270 degrees. And then for each of those images, it creates a duplicate black and white image. So you kind of get, a range of variability within your imagery data that can help your model better identify that specific brand. We're going to be looking in the data directory. You can change the name to whatever you want it set to, but as long as the structure remains the same, you should be good. Here I have the picture size set to 244. Now you may want to adjust the picture size, but that's going to be dependent on the type of system that you're running it on. I'm running it on my laptop, so it's got a 4090 RTX GPU, so it's pretty good. It handles the 244 pretty good. So that's what we're going to be resizing to. Here we just basically go ahead and make sure that the image structure, the data directory, is structured properly. Then we're going to go ahead and display. I'll actually just run through this as I'm speaking through it. That way we don't have to go back through and run this. So we're going to do the loaded libraries, enforce our directory structure, create the folders if needed, add the log message, go ahead and set our variables, go ahead and set our data directory. We'll pull the structure verification to make sure that everything is valid. It should come back. Okay, so it is valid, so we're good there. Now we're just going to run through and go ahead and display some random images from the directory. So it's already pulling up the images from the actual labeled directory. So it's Microsoft, Ubuntu, Louis Vuitton, Microsoft, Nvidia. So it's just randomized actually, Nvidia. Now we're going to find all the subdirectories, and what we're going to do is assign the name of the subdirectory to each class as a label for the training data. So we got that. Because we don't want to, if we want to retrain, we're going to go ahead and back up our original data set into a directory called original data. Now, Here's a key part. We're going to go through and any abstract image file names like GIFs, PNGs, WebPs, we're going to convert them all to a straight JPEG. So we'll do the GIF, PNG conversion, WebP conversion, and I think we're going to convert any JPEG to JPG area. Now, one of the key things that gets missed in a lot of this is actually balancing the data set. So if you use your own data and you may have it skewed, you may have certain, a higher number of images in a given group than another, you want to make sure that you balance the data set so the model's predictions aren't skewed as well. So what we're going to do with this is we're just going to come in and take the directory with the lowest level of images or the lowest number of images, and then we're going to remove all of the images in the other directories until each directory has the exact same number of images based on the directory with the least amount of images. So that's all that that's doing right here. Ensure that our data set is balanced. And now we have our labels. And now we're going to go ahead and resize all of the data. So it's running through and resizing every image in every directory to make sure back to our 244 standard. And now here's where we create all of our auxiliary data. Or here's where we augment our data. Now let's go ahead and get a count of everything that's happening. There we go. So we log the count. Now we're going to, and I do this just as a means of shuffling image names. So what I do is I actually just rename every image in the directory between 100,000 and 200,000. You can change the numbers, or you could skip this rename function if you want to. But for me, it's just a way to kind of go through and ensure that I shuffle the image data. So let's go ahead and do that. This is important. So color images are 3-channel, black and white are usually single channel. So what we do here is we just go ahead and ensure that all of the images are 3-channel data. So now we're going to verify that every image in each of the training directories are JPEGs. That came back clean, so we're good. Then we're going to loop through each directory to find any possible truncated images, any images that didn't get written correctly or maybe broken or things like that. So anything that's going to adversely affect the training of the model. Now, as a final push, we're going to we're going to remove every non.jpg file in the entire structure. Here's one of the added benefits of using this image utilities for data preparation. This goes through and it splits your data into the training and test data sets, doing 80% training, 20% test, or validation. So this kind of saves you the trouble of having to mix it up. So we've removed any leftover files, and now we're going to move all of the prep data directory out of the images directory. So that way we're just making a copy of what we've prepared as well. Logging that, and now we're at the actual end of this specific notebook. And if you remember before when I said you could set the auto run to true to go ahead and call the TensorFlow trainer, and if we would have ran through this with that set to true, it would actually kick off the TensorFlow notebook and begin training from there. So that's all we have for the image utilities and preparing our data set for the model training. Next, we're going to get into training our actual model on the image data that we've just prepared. Now that we've completed running the data prep on the image directory, what I wanted to go through and show you was the actual log file that gets generated as we're running through these steps. So we're starting off, it lets us know that our directory structure is valid. Here's where we're displaying random images. We're verifying, displaying the images. And if you remember in the video, I ran it twice. So then I went back and ran it from the start. So that's why you kind of have some duplicates here. Here's the output of all of our directories with each of our labels. Backs up the directory. Here's where we copy over all of the data to the original data directory. Here's where we're converting all of the PNG, GIF, and WebP and JPEG files to .jpeg file extensions. Here's where we're going through and actually balancing our data set. Here's the resize. Here's where we're augmenting each of the classes or the different directories of images that we're using as our classes. And here's where you see it comes back that all of the data sets are actually balanced at 544. We're going through and renaming all of the images in each directory, ensuring that all of the images are 3-channel. And now we're going through and verifying that all of the images are .jpeg images and they're valid. Here's where we go through and identify any truncated images. So it returns a 0. That's the truncated images found in each directory. Here's where we're removing all non-JPG image files. Here's where we're going into our training test split. And here's the output of the files from the training test split. So class Mercedes 436, and there's 108 validation files, and it should be the same for each class, and it actually is. So then it moved the prep data out of the actual data directory and into the root folder. So now all we have to do is run our model trainer, and it's going to look in the data directory and find only the train test split data. So to continue on with our multi-class image classification model trainer, here we're going to jump into the PyTorch model trainer notebook. It's pretty straightforward. Once again, it's not an advanced level notebook, so it's just basically a walkthrough to get you up to speed in fine-tuning a ResNet 50 model trained on your own image data set to perform predictions. We're also, once again, going to use the logos from before, the data that we prepped in the image utilities notebook, and just run from there. I do want to highlight a few things. I am using only 10 epochs, and I'm setting the batch size to 250 with image size of 244. I would caution to manipulate these variables to fit the system that you're running on. If you're running on your laptop, you may need to decrease the batch size and up the epochs to get the desired level of accuracy that you may be looking for or trying to get. Once again, this is a basic model trainer. It's probably not going to get production quality model from this, but it's just to walk you through the steps to get you end to end from image data prep to a viable proof of concept model at the end, PyTorch model. So I'm just going to kick it off and watch it run. You'll see it's printing out all the stats, and we're actually writing to the log file that we just viewed, so we can kind of go back and check if anything breaks or if there are any inconsistencies. Try to look through the log and find out what's happening. We're showing our sorted classes here, building the configurations, letting random seed. So here's a pie chart for our label for our actual image data. So data distribution showing that we do have a balanced data set for test as well as validation. You can go ahead and just cursory glance, see they're all 108, and for the test set, they're all 436 images per class. So here's we're starting to put in all of our data operations for the loading the imagery data into the model. Here's our random plot function to grab random images just to validate that it's pulling properly. So we can just do a quick look. Adidas, yes. Ubuntu, yes. Nike, Nvidia, Nike, Louis Vuitton, Mercedes, Adidas. It's not going to grab a sample from every class. It's just randomly grabbing images from the data set. This is where we're looking at our model state dictionary, and we're printing it out, setting our optimizer and our learning rate, building the training function, the evaluation function. Here's the graph to show our performance plot, the cross-entropy loss versus the accuracy. And here's where we're calling our train and eval functions. And this is starting our training. We're actually in the correct data directory for the training. You see us going through. We're almost done. We're at 9 epochs right now. Once again, to increase the accuracy, add more data, add more epochs, up your batch size to converge faster, but these are parameters that you're going to have to play around with. Once that gets completed, we actually save our model right here in our model directory. Then here's where we're going to show our features of the model, and here's our performance. High 80s, low 90s looks like. Our confusion matrix, it's not going to be too complicated. 89.20% accuracy, that's pretty decent. So here's where we're going to test our model with random images. This is just a function I'm passing in, and we're looking at 38% confident this is a Nike logo, that's correct. 59% confident that's Ubuntu, that's correct. And you could just go through and see Nvidia, yes, that's correct. Nike, yes, that's correct. Ubuntu, once again, correct. Mercedes, yes. Apple, yes. Adidas, yes. And it's missing on this one. And it also prints out the confidence for each prediction, so that's pretty good. So here we did 84 Nike, so
there you have it. We have a PyTorch model based on the ResNet architecture. And I'll go ahead and pull up the model directory to show you specifically where you could look and find these outputs. If you wanted to go back and look at you can go into the model folder, and there you have it. So this is the second running, so this comes up V1, and there is an auto increment. If you want to just run it and run it and run it, it will do a version 1, version 2, version 3. But here's your model, and here are your run files. So you can just take a look and see the difference. So here's the torch validation. Version 3 is the latest one we ran, but the validations are going to be the same, 108. And here is the training, version 3 training. So you see 430. This is just a way that if you clear out the notebook, you still have these saved in here. So you can go back and check. And there's your confusion matrix. So there you have it. That is data prep, multi-class image classification model using 2 separate notebooks. Thank you again. FalconsAI 125.